5-4, solving systems using linear combinations. Mr. Johnson calls this the elimination method. And I'm pretty sure I referred that to you when you were in Algebra 1. But elimination method is you're getting rid of a variable, so you only have one variable, and then you're able to solve. So the big idea is some systems of equations can be solved by creating a new equation that is a linear combination of the original equations. Okay? If in the elimination method, you can multiply one or both equations by some number. Okay? You can multiply both equations or one equation by some number so one variable gets eliminated. It says in the last lesson you solved systems using substitution property, which may be faster than using a CAS in cases when one equation is already solved for one variable in terms of the other variables. When linear equations are written in standard form, it may be more efficient to solve the system using the addition and multiplication properties of equality. Recall that an expression of the form am plus bn is called a linear combination of m and n. In this lesson, we use what we call the linear combination method of solving systems because it involves adding multiples of given equations. So if you look at example 1, it says solve the system x plus 2y is equal to 11 and 3x minus 9y is equal to 23 by the linear combination method. So what I'm looking for here is a way to get either the x or y is gone. Okay? If I look here, if I add these two together, I get 1x plus 3x gives me 4x. 2y minus 9y is a negative 7y. So they're not automatically going to fall out when I add them together. So I need to multiply one of these by some number, or both of them by some number. But if you look at this, if I multiply the top one by a negative 3, this would give me a negative 3x, and then plus 3x would give me 0, so my x's would be gone. Now, when I multiply the top one by a negative 3, you got to make sure you do it to every single term in the equation. Otherwise, you end up changing the whole format. So we don't want to do that. You have to do it to every single thing. So if you do multiply by 3 to every single thing, or multiply by a negative 3 to every single thing, when you do it to every single thing, it doesn't change anything. So a negative 3 times x is a negative 3x. A negative 3 times 2y is a negative 6y. And a negative 3 times 11 is a negative 33. I rewrite the second equation. 3x minus 9y is equal to 23. And now I'm going to add these together, because that's my goal. I add these together so something falls out. Well, a negative 3x and a positive 3x is 0. A negative 6y and a negative 9y is a negative 15y. A negative 33 and a positive 23 is a negative 10. Get y by itself, I get to divide by a negative 15. And y is going to equal, a negative divided by a negative is positive. 10 divided by 15, you can just leave as 10 divided by 15. Fractions are fine. Leave it like that. So I found my y. What happens when we get a solution to these problems is, what we normally get is a coordinate point, an x comma y. So in this case, I'm only halfway done. Why? Because I found a y, I haven't found my x. So my answer is only halfway done. So this is 10/15. But since now I know what y is, I'm able to put it back up into one of these equations and find out what my x is. So that's what we're going to do. Use 10/15 to find out my x. So I'm going to put it back into the top one. x plus 2 times 10 to the 15th power, or 10 divided by 15, sorry, not to the power, equals 11. Okay? So, 2 times 10 divided by 15, you're going to tell me is 20 divided by 15, right? And then to get x by itself, we have to subtract 20/15. And x is going to equal, and I'm just doing this on my calculator, but 11 minus, don't forget parentheses, 20 divided by 15. You are going to get out 9.6 repeating, which is 29 thirds. So 29 thirds, comma, 10/15 is where my two lines intersect at. That's where those lines are going to intersect at to give me my solution. Okay? So, moving on. Example 2 says solve the system 2x plus y plus 4z equals 20, 3x minus 3y plus 2z equals 27, and 4x plus 5y minus 2z equals 4. If you notice, we have 3 equations and we have 3 variables. So what we have to do is use 2 equations to get us down to 1 variable, the other 2 equations to get us down to 2 variables, merge those together, get it down to 1 variable, and so on and so forth. So this is going to take a couple slides, and I just want you to pay attention to how I do this. Now, I'm going to pick out this first equation, and why is this one important is because it only has a y here. So I'm going to use this equation with the other 2 to get me down to just x's and z's. So I'm going to put 1 and 3 together, or 1 and 2 together, and I'm going to put 1 and 3 together. Okay? So 2x plus y plus 4z is equal to 20, and 3x minus 3y plus 2z equals 27. Now, I want to get my y's to fall out, so I need to multiply everything up top here by 3, and I'm just going to write that above everything. So that gives me 6x plus 3y plus 12z equals 60. Okay? Now, it's like this ain't even there anymore after I multiplied by 3. So when I add these together, 6x plus 3x is 9x. And 3y and a negative 3y are add out. 12z and 2z is 14z. And 60 plus 27 is 87. So as you notice, I got down to my x's and z's. I got to do that with 1 and 3 here. So 2x plus y plus 4z equals 20, and 4x plus 5y minus 2z equals 4. And I'm just going to erase this out of the way here. This was 1 and 3. So I'm going to multiply. I got to have this be a negative 5. So I got to multiply everything by a negative 5 here. So this gives me negative 10x, negative 5y, negative 20z equals a negative 100. So that's like this ain't there anymore. So when I add these two together, I'm left with a negative 6x minus 22z equals a negative 96. Now, I'm going to put this over with this other equation. So a negative 6x minus 22z is equal to a negative 96. Now what I need to do is get rid of the x or z's, okay? And what I'm going to do is I'm going to multiply this by 2, and I'm going to multiply this by 3, okay? If I multiply this by 2, that gives me 18x. If I multiply this by 3, it gives me a negative 18x. So I'm going to move that over here to give me a little bit more room. So it's going to be 18x plus 28z is equal to 174. We have to multiply by that 2 through everything. And so a negative 18x minus 66z has to equal a negative 288. And as you can see, when I add these together, my x's are gone. It leaves me with 38z equals 114. Divide by 38. Divide by 38. Sorry, you can't see that. And z equals 3. Now, that I know that z equals 3, what I can do is put it back into one of these equations right here of my x and z and find out what my x is. So I'm going to go right back up here. I'm going to write in 9x plus 14 times z. What's z now? Z is 3. Equals 87. Well, 14 times 3 is 42, so I'm going to subtract 42. Subtract 42. Leaves me with 9x equals, and when I subtract that, I get out 45. So looking at this now, I know x is 5. So I know x, I know z, I need to find out my y. So I'm going to go right back up into this equation. 2 times x. Well, 2 times x is 5. Plus y plus 4 times z is 3. Has to equal 20. Okay? Well, that's 12, and that's 10. So 10 plus 12 is 22. So y plus 22 has to equal 20. Well, if I subtract 22, and I'm sorry for all the mess, if I subtract 22, I get y is a negative 2. So if I'm going to write this as my coordinate point, I just found x, y, and z. So if I'm going to write this as my coordinate points, you go alphabetical order. So x is 5, y, z. Y is a negative 2, and z is 3. Now that's a lot of work for one problem, and when I get back, I'm going to show you how to do this problem easier using your matrices and on your calculators. So let's move on. If you noticed, the systems in examples 1 and 2 are consistent. That means that they intersected at some point. Okay? And each has a unique solution. However, suppose you try to solve systems such as these two things. Okay? If you look at the first one, okay, if I'm trying to get out a x, I would multiply by a negative 1. So this becomes negative, this becomes negative, this becomes negative. As I add these together, a negative x plus x gives me 0. A negative 2y plus 2y gives me 0. And a negative 11 plus 12 gives me 1. Well, does 0 equal 1? No, that is not true. Therefore, there is no solution. These are inconsistent. So much like we found out before, doing them with substitution, you can still find out if they're inconsistent using this method as well. It just gives you another tool on how to solve these problems. Well, what about this second one here? Well, here we'd have to multiply by a negative 2 because this is a positive 2x, so I would multiply this by a negative 2x. So this would give me a negative 2x. So I'm going to multiply by a negative 2. A negative 4y, and would give me a negative 22. Okay? I leave my second equation because everything's going to fall out for me if I leave it. So, negative 2x plus 2x, those are gone. Negative 4y plus 4y, those are gone. So it leaves me with 0 on the left-hand side. And a negative 22 plus 22 gives me 0 as well. Does 0 equal 0? Yes, that is true. Therefore, we have an infinite number of solutions, and this system would be consistent. That's all I have time for today. Please enjoy. We'll see you tomorrow.